Hi guys, you caught me on Star Wars Day, so may the force be with you, wherever it was. I'm going to model how to calculate net force. So net force is a new thing that we're going to be learning about. Some quick vocabulary here. A force in general is just a push or a pull on an object. It can be pushing it towards the left, towards the right, toward up or down. If you're talking about like directional, it can be like northwest or westward or something of that sort. So just any direction, a push or a pull. Net force is the total force on an object. So you have these forces pushing in either direction. So if I were like to push my head towards this way, but it's like, oh, my hand, this is my weaker hand, is pushing my head this way. Well, which one is going to win? Possibly my stronger hand because it has more force. So the total force on an object is not, I'm adding this force, because they're going in the opposite directions. Some of it kind of cancels out, and then the stronger force overpowers it. So my head goes one way. All right, so you can think of it like that. Let's review what like balance and unbalanced means, because if you have a balanced force, they're equal in opposite directions. So they cancel each other out. So the net force here would be 0. The net force would be 0 with a balanced force. Because there is no force acting, it is balanced. An unbalanced force can move an object. Okay, it causes the object to like either stop moving or start moving or change directions. And I know like the stop moving one may be kind of confusing, so I'll probably omit that and we'll move on to it. Also, it can cause something to stop. But anywho, a balanced force would look something like this, both equally distributed. This person balances with this person on the seesaw. However, if I have an elephant and a mouse on a seesaw, we can assume, based on the positioning of the seesaw here, that the elephant has more force pushing downward than the mouse does, okay? And if you look into the force formula, which we will go into later, and you also saw on our t-shirts, I know this is more complex than you need to know, but mass, this M is involved, okay? When mass is involved, it affects the force. More mass, more force. You've probably heard the bigger they are, the harder they fall. That is true. Okay, so let's practice calculating net force with Lily. Some really important rules here that we're going to add for you is that if arrows are going in opposite directions, we subtract. When arrows go in the same direction, we actually add. So some diagrams here, this is showing you like how you can calculate net force. This is like very simplified for you, and we're going to help you out here. So here's Lily. Sometimes Lily is in a little stroller because she's getting older, so she needs some help moving around. And well, it looks like she's having a pull here of 20 newtons. But it seems like there's an opposite motion here going toward the left, so we can assume that's like friction. Okay. So to calculate this, let's go back to our rules. Are arrows going in the opposite or the same direction? They are going in opposite directions. One is going toward the left, one is going toward the right. So that means that we subtract these forces. Always subtract the bigger number from the smaller number. So it would be, I want to see if I can do this in a nice color for you. Maybe make it bigger. Okay, 20 minus 10 equals what? Yep, 10. Easy peasy. So that's 10 newtons. Now, when it says direction, it's asking us, like, well, where is this guy going? Like, where's Lily going to go? Is Lily going to go toward the left or toward this arrow or toward this arrow? The easiest thing to remember is that object with the unbalanced forces, that object will always move toward the arrow with the greater force. Okay, it will always move toward the arrow with a greater force. So you can stop and you can write this down somewhere on your packet. The direction will always go toward the greater force. So it is going towards the greater force initially, which is the 20 newtons, which means that the direction is going towards the right. Okay, I do this because I'm mimicking the actual classroom environment. 10 newtons, so for 10 newtons, going to the right, all right? And that's what you put here. Now, since this is 10 newtons, we remember this from last week, this is actually a number. There's an amount of force working on this object. Since there's an amount of force working on this object, is this balanced or unbalanced? You should have said balanced. Okay, so it is balanced. Oh, sorry, just joking. I caught you. Unbalanced. Apologies. Unbalanced. Because there is an amount here of force working toward the object. And look, the object is going toward the right, so it is unbalanced. Awesome. And that's how you figure that out. Let's try the next one. You can pause this at any time as you're moving on. Cool. So let's look at number 2 practice. This is Lily sleeping. And it looks like here gravity is pushing down with 15 newtons of force. And then there's like the normal force of 50 newtons. Cool. So we have to write it down. So are they going in the same or opposite direction? This is something that we always have to do. Are they going the same? Arrows going in the same or opposite direction? They're going in opposite directions because one is going down and one is going up. So since they're going opposite, we are subtracting. So you subtract the 50 newtons minus the 50 newtons equals, yep, 0 newtons. Exactly. And is this object moving? Nope, because it's 0 newtons and you can just put not moving here. I know you can't really see it, but you know what it is. So because it is 0 newtons, is it balanced or unbalanced? Cool. So you should put, I hope many of you answer this correctly, balanced, because no movement and arrows going in equal, yes, opposite directions. So it's the equal amount of force in opposite directions, and that is a balanced force. The equal amount of force in opposite directions. You can write this down. Equal amounts of force in opposite directions. It's also written for you over here, but worded a little differently. All right. So last one is moving on to number 3. This one's interesting. This is Lily playing in the snow. She has her moments. So let's talk about the net force and direction here. So are these arrows going in the same or opposite direction? These arrows are going in the same direction. So since they're going in the same direction, you have to add. This is different. So you can just add in any one. So it would be 50 plus 10, which gives you 60 newtons of force. But where is the direction Lily is going? This may be super easy because it's a picture of her literally running, but yes, she is going toward the left. Going toward the left. You don't know your left from your right. You can have someone help you out, like, put L's in front of you. And if the L is facing just like the same way you would write it out, that's your left hand. Okay. So it's going toward the left. Another reason that you can determine where this object is going, well, both you can go yes toward the greater force, which is just toward the left, because that would still work too. But also, since both of these are facing toward the left and there's nothing facing toward the right is just like 0. So it would just keep going toward the left. All right. So based on this, since it's 60 newtons, is this object balanced or unbalanced, the system? Yep, it is unbalanced because there is movement going on. Okay, perfect. So go ahead and practice this. There's a few things that you need to practice. You're going to practice calculating net force. We put this up here for you so you can use it. If you have any questions, ask your teacher. This is great group work for you to do if you do group work. If not, then try your best. Okay? All right, bye.